again. This is the simulcast for Evenings of Enology. So I've got a camera over here that I'm looking at, and I've also got a camera over here that I'm looking at. So you'll have to pardon if I'm looking like this all the time. I am personally really excited about this episode. So I will be doing most of my episodes solo. Hey, I'll be doing most of my episodes solo from here on out because there's this little thing called harvest going on. And what harvest means is that I can no longer rely on winemakers to know their schedule or know what their life is going to be like. So the only thing I can really count on as far as scheduling right now is myself. So the rest of Evenings of Enology will be just hanging out with me, unless I can get a winemaker who can reliably tell me that he or she or they are going to be able to join us. So today's rad. I have been looking forward to this episode for a while. This episode is near and dear to my heart because it discusses how the chemistry of wine can affect how you buy a wine and how you think you enjoy wines. And so the first part of today, we're going to go through basic structure of what's in a wine glass. And then the second part of today's episode, we're going to talk about ways that people in the wine industry can blind a wine, which I think is going to be controversial because I know that people out there think it's kind of garbage sometimes. But there are distinct chemical characteristics that we look for in certain wines to help us decide what a wine is and whether or not we like it, honestly. So this would be a great episode for you to have a glass of wine and let me know what you're drinking. And if you do have a glass of wine and you are drinking it, we can kind of talk about that glass that you're having and whether any of these things that we're talking about have a significant role in the wine that you're drinking. So today I'm drinking what was open in my house, which is lovely though. It's a Grenache Blanc from Paso Robles, and we'll use it to talk about a couple of things that we're going to be discussing today. But it's not actually like super high in a lot of the things that we'll be mentioning today. So, and also if you have any questions, I have the chat open for Nexus, and I also have the chat open obviously for the Instagram live. Please feel free to ask any questions. I'm hoping this is a very highly interactive episode. I don't drink alcohol, but interested. Cool. Awesome. I actually know a winemaker that doesn't drink alcohol. So that's not that uncommon, actually. All right. I guess without further ado, let's talk about basic structure of a wine. So within wine, you have four main structural components besides water. Duh. You have alcohol, sugar, tannin, and acid. So alcohol is the thing that makes wine and not just grape juice. Alcohol gets made by the conversion of sugar into alcohol and CO2. So way back in the day, a dude, I'm sure a lot of us know, named Louis Pasteur was the person to kind of discover and demonstrate experimentally that fermented beverages arise from the action of yeast, and that fermented beverages give rise to ethanol, and that ethanol comes from sugar. And originally, Mr. Pasteur defined this as respiration without air. So an important thing to realize is that the fermentation of grape juice into wine is anaerobic. And so what that means is typically when you're taking sugar in and you're trying to convert it into something else for energy, usually you would go through the pathway called glycolysis. And then that would go into the Krebs cycle. Does anybody remember that stuff from biochemistry, Krebs cycle stuff? If you have a sugar that goes through this cycle, you get around 36 to 38 ATP molecules for each molecule of glucose consumed, right? Like if we scratch our heads, we're like, tricarboxylic acid cycle, that's a thing. Yeah, so, but in wine, that doesn't happen. So in wine, we have an anaerobic environment. And what happens is instead of taking that sugar down the pathway of the tricarboxylic acid cycle to get buckets of ATP, we actually have that going through a pyruvic acid cycle during glycolysis. Sorry, I think I messed up my words there. Thank you for catching me. You have the tricarboxylic acid cycle where you get buckets of ATP, and you have glycolysis. And when you have glycolysis, you go through the pyruvic acid cycle. And that pyruvic acid is what actually gets converted into ethanol. And so this happens in anaerobic environments. And so that's how we get wine. So that's how we get ethanol. And that's how we also get CO2. I was working with an intern just this week, and he accidentally stuck his head into like a fermenting bin of wine and was like, oh my gosh, because he almost asphyxiated himself because there's just CO2 falling out of that bin, right? So be careful when you're making wine. You don't want to asphyxiate yourself. So oftentimes people, when they are trying to decide if a glass of wine is good or if they enjoy it, you'll hear this thing called legs. And people oftentimes associate legs with ethanol. And while ethanol does contribute to the legs of a wine, there's also anything that contributes overall viscosity to a wine. So sugars, which we'll get into next, also create viscosity into a wine. But ethanol as a structural component of wine is something that you can look at that needs to be in balance. So if you've ever, again, this is the zone of no judgment, but if you've ever taken a shot of vodka and exhaled, you'll feel a little bit of a burning sensation. And so if you have a situation where you're drinking a wine and you're like, whew, man, this is kind of spicy, and you blow out, the odds are that glass of wine is not incredibly balanced in its ethanol concentration. And these are things, we're going to think about the four main structural components of wine sort of as a painting. And there are things in paintings that stick out and look kind of funny. So one of them could be ethanol. If you blow out and that ethanol is burning your mouth, it's too high in ethanol. You may not like that. Some people may love that. I personally don't love when my ethanol is out of structure. Another thing in wine, one of the four main structural components of wine is sugar. So most wines that you buy in a grocery store are going to be fermented dry. But there's a term that we can think of called residual sugar. And residual sugar is any sugar that's left over at the end of fermentation. And that sugar can be left over because the yeast crapped out because your alcohol concentration got too high, as is the case with dessert wines sometimes. Or you can stop your fermentation because you have a desire to have residual sugar. So another thing with sugars that is kind of cool is there's what's called a threshold of perception with residual sugars. And that concentration is 2 grams per liter residual sugar. So you can actually have a wine that is on a shelf that has residual sugar, about 2 grams per liter residual sugar. And from a consumer standpoint, you're not going to be able to taste it, but it creates viscosity and silkiness and like kind of a softness to the palate. And sugar is another thing that can contribute to the legs of a wine. So if you take your glass of wine and you swirl it like all the fancy kids do in all the fancy wine movies, and you see legs coming down, those legs can be a function of ethanol concentration. They can be a function of sugar concentration. They can also be a function of glycerol concentration. And we'll talk about glycerol a little bit later when we talk about a fungus actually called Botrytis. Botrytis tends to create a high glycerol content in wine. So far, we've got alcohol. If it's too high in alcohol and you blow out, it's going to feel like you're taking a shot of vodka a little bit. We have sugar. If your sugars are high, it's going to create this kind of viscousy, kind of sweet, obviously, rounded, soft mouthfeel. And you can get residual sugar from either crapped out yeast, too high of an alcohol concentration. You can also add it back in afterwards sometimes, or just from a winemaker stopping a fermentation. Or if your fermentation gets stuck and you're like, screw it, we're done. Another thing in wine that contributes to structure of a wine is a thing called tannins. Tannins are complicated. So within tannins, and please ask any questions, like if you want any clarification on anything, I'm totally happy to attempt to clarify any of these questions that you have, because this episode is, again, about a consumer standpoint. I'm just trying to give you the tools to have in your back pocket to know what you do and don't like about wines. So tannins, back to tannins. So tannins are polyphenols, and they can come as monomerics or they can come as oligomeric chains. And those sizes of chains are going to change as a function of time. And those can be either short chains in the seeds or long chains in the skins, or even longer chains as a function of time. Because as a function of time, these oligomeric units are going to polymerize to be even longer units. So let's back up. So let's talk about some of the monomeric units first. So we have 3 primary classes of what are called flavonoids. So if you are a chemist and you've ever studied flavins or flavonoid rings, you may have a general idea of what I'm talking about. But they are, these rings that are in a conjugated pi system And there are 3 primary classes within wine. You have flavin thiols. These are huge. So these are called like catechins or epicatechins, and these are what we're going to talk about mostly when we consider polymerization. We have flavanols, which aren't incredibly important in as far as the structure of a wine is concerned in both the young wine and the more mature wine. But they are found in the berry skin, and they seem to help as like essentially like a sunscreen. So that's kind of cool. And that comes in handy sometimes because grapes do sunburn. So just like you, grapes can sunburn. So if you are in like super hot Central California and you don't take care of your canopy on your vines very well, you can actually sunburn your grapes. So, okay. Another class of monomeric phenol compounds are anthocyanins. And anthocyanins are the things in wine that give rise to color. Anthocyanins are actually really freaking cool too. So anthocyanins are these three ring compounds, and those 3-ring compounds can also, they are conjugated pi system, if anybody knows what a conjugated pi system means. So they have electrons that are kind of dispersed throughout that ring, right? And they can actually pi stack and create this like visual difference in color in wines, which is pretty freaking cool. So anthocyanins are the 3rd class of monomeric units that you can actually see in red wines. Someone asked on Nexus, what happens if a grape gets sunburned? So if it's a fruit, right? So grapes are still fruit. And so if you sunburn a piece of fruit, it's going to caramelize. And that's going to change the overall structure of how that wine tastes. And it's going to change what's called your ripeness of fruit. It can also change your phenolic composition, which means that it can change how those phenols that we've been talking about express themselves in a final wine. And so typically if a grape gets sunburned, that is frowned upon. You can deal with a little bit of sunburn, and you'll see that oftentimes in white wines because they're pretty prone to sunburn. But it's something you typically want to avoid, and you typically want to avoid it with canopy maintenance. So silicylate of wine. Are you talking about diatomaceous earth potentially? Can you clarify that? I don't know exactly what you're talking about, but I want to. That was a question over on Instagram Live. So I feel like caramelized grapes would taste pretty good. Sometimes they actually do taste really good. So within tannins, we've been talking about these monomeric units. We have flavin thiols, which are important because they're the monomeric units that are going to polymerize. We have flavanols, which are basically like sunscreen. And then we have anthocyanins, which give rise to color. Within those 3 classes, those flavin thiols can polymerize. And this is important. Those flavin thiols are the units that can polymerize to create long chain polyphenols. And if has anybody ever been able to actually eat like a Vitis vinifera or a wine grape berry? Anybody? If you have, if you haven't, come hang out at my winery. We're in harvest. I'll give you a berry. If you've ever eaten a berry, it tastes like fruit, obviously. But what's really cool about it is if you take that berry and you eat it, you're first going to get that sugar and that acid like you would with most fruit. And you're going to get this kind of like astringent sort of taste. Very, very minor, but astringent nonetheless. Then if you bite into the seed, it's going to get very astringent. So the difference there is that the tannin composition or the polyphenolic composition of that grape differs between the skins and the seeds. So the seeds have very short units of polyphenol oligomers. So it's anywhere from like 3 to 5 units of those flavin thiols. The long chains and the skins can be anywhere from 30 to low 40 oligomeric units. And so the longer that oligomeric unit is of polyphenols, the softer the tannins feel on your palate. And so what tannins feel like on your palate is they feel like when you go to the dentist and the dentist shoves that piece of cotton in your mouth and it's like absurdly uncomfortable and it dries out your mouth. So if you're ever trying to see if a wine has a high tannin composition, just see if it's pulling things out of your mouth. Because what those polyphenols do is they actually bind to fats and proteins, which is why oftentimes you'll see like big, robust red wines that are being paired with really high fatty foods or with meats or charcuterie plates or something like that, because those polyphenols physically pull them out of solution, those fats and those proteins in your saliva. And when you don't have any saliva in your mouth, it feels kind of dry. So that's what tannins do. One of the things tannins do. Tannins are also antioxidants, and that's really important as far as the aging of wine is concerned. Someone asked, where is my winery? My winery is in the Santa Cruz Mountains. If you want to come hang out in the Santa Cruz Mountains, or if you're anywhere near the Santa Cruz Mountains, let me know. I'll be there a lot in the next month and a half. So, 'cause harvest. Okay, so that's tannins. We have one more primary component of structure in wine before we get to all like the other fancy weird shit. So remember, again, ask any and all questions. This is the zone of no judgment. We all didn't know wine at some point. Believe it or not, I didn't come out of the womb drinking wine. Kind of too bad, but I didn't. And so I had to learn all these things as a function of time as well. So, okay. One of my favorites, acids in wine. So there are a lot of organic acids in wine. There's also some inorganic acids, but we're going to talk about all the organic acids today. So if you take a grape in, one of the first things we test when we're in a winery, when we're trying to decide when to pick a grape for actual production, is what is the pH, what is the titratable acidity, and how much sugar is in it. So Brix, pH, TA. We discussed these 2 episodes ago with Abby, but that's because pH and TA are incredibly important. And the pH of wine is very low, and that's what allows us to age it for one of the things that allows us to age it for a long time. And titratable acidity is pretty high. So as a function of fermentation and as a function of time, your relationship with pH and TA in general, of course, there's always exceptions to every freaking rule, right? But in general, pH and titratable acidity are going to have an inverse relationship. So what that means is as the fermentation goes on, your titratable acids are going to drop and your pH is going to increase. And that's because of a couple of processes within fermentation as well that we'll talk about in just a hot second. But acid is very, very important in wine. And what acid feels like, and this is nice because this wine is high in acid, like moderately high in acid. It's mouth-watering on the back of your palate. And so when you're tasting a wine in a wine shop, and this is a lot easier sometimes to detect in white wines than red wines. Again, if you're drinking a wine, let me know what you're drinking so we can talk about your wine as well. Acids are going to give you that mouth-watering kind of lingering sort of feeling on your mouth. And I love high acid wines. They're so much fun. They're so delicious. And they also contribute to the ageability of a wine. So the pH of a final wine is going to be anywhere from, Germany has some really low pH wines, and a couple of other cooler regions have low pH wines. But you're looking at anywhere from 3.1 to like 4.0, more or less. And certain grapes have lower pH, certain grapes have higher pH when they're in their final wine form. When grapes are coming into the winery, you'll see anywhere from high 2s to low 3s. I mean, these are, again, very, very generic, but those are your approximate pHs. The acids that we see in wine that we're going to talk about for organic acids, we have malic acids, tartaric acids, succinic acids, citric acids, and acetic acids. Sorry, someone just asked, hey, Tony, sorry to go back. Is there any relation between tannins and oakiness when it comes to a wine flavor? Fantastic question. And I actually like that you mentioned that because I point. I'm so sorry. I hate that I point. I actually didn't know if I wanted to talk about oak tannins or the relationship between oak lactones and wines and tannins, but there is a relationship. So I mentioned that there's tannins in the seeds and the skins of wine grapes. There's also tannins in the barrels that we oftentimes age our wines in and maybe ferment our wines in. And there's also tannins in the stems as well. So you are going to gain a phenolic contribution from oak as well. And you're going to be able to feel that as well. And you're also going to gain what's called oak lactones. And we can talk about lactones a little bit later, but they are a chemical that gives you that kind of vanillin sort of flavor that you typically associate with a toasted new oak barrel. So absolutely, there is a relationship between tannins and oakiness when it comes to wine flavor, and those tannins from both the stems and the seeds. Sometimes the stems, the seeds, the skins, and the oak all interplay to create an overall phenolic profile of a wine. So fantastic question. Okay, back to acids. This is really weird doing it by myself. I don't know. I'm kind of like it. I kind of don't. Kind of miss my homies. Okay, so acids. So we have malic acid, tartaric acid, succinic acid, citric acid, and acetic acid. So acetic acid is, let's start with the big acids. So tartaric acid. Tartaric acid is going to be your highest concentration acid that you have in both the grapes coming in and in your final wine. And that's going to be on the scale of grams per liter. So it's very high concentration. You have malic acid. Malic acid is an acid that you find in, I don't want to say that actually. Let's simplify it. Malic acid is the acid that you can find in a lot of grapes that contributes to this sort of green apple character. And so if you have a wine that hasn't gone through a process that we'll talk about in just a second called malolactic fermentation, it's going to taste very green apple-y. So I was actually drinking this, I'm drinking it now as well, but I was drinking this wine earlier and trying to decide if I think it's gone through malolactic fermentation. Because it has a really rich sort of nose profile that would lend me to think that it has gone through malolactic fermentation, but it's also got this really crisp green apple Asian pear thing on the back of my palate. So I wouldn't be surprised if it went through either a partial malolactic fermentation or no malolactic fermentation was just aged in oak to give it that kind of sort of savory flavor, but I don't know the winemaking on this. That would just be my guess. You have a couple of acids, succinic acid, citric acid, that are at low concentrations, and then you have an acid called acetic acid. And your levels of acetic acid is going to be around. It's the same acid that you think of when you think of vinegar. But there is a legal limit to how much acetic acid you can have in a wine, and I think it's around 1 gram per liter. And you're going to see numbers on a normal par for your course wine, and that number is, I believe, only. I'm just going to stop before I say something wrong, actually. So it's about 1 gram per liter, and you'll see numbers anywhere from 0.3 to 0.7 grams per liter. Anything above that, and you're going to start getting an effect called volatile acidity, potentially, where it just smells like vinegar. It's pretty easy to detect because you can physically heat up your wine just a little bit, and you'll be able to smell vinegar suddenly. So that's an acid in wine that is actually undesirable. So those are your primary acids in wine. And then I threw out this fermentation word just for a hot second called malolactic fermentation. This is oftentimes referred to as a secondary fermentation. Your primary fermentation, and we're talking about still wines here, your primary fermentation being the fermentation of sugar into ethanol and CO2, and your secondary fermentation for these still wines being malic acid into lactic acid. So malic acid, again, being that green, apple-y kind of flavor, and lactic acid being that savory, kind of lush, almost buttery flavor, but not quite butter. But savory is a word I like to use, even though it's super generic. Malolactic fermentation will happen in all reds. I hate all, but I'm just going to say it. In all reds and in a handful of whites. So those are your acids. And so what I just covered is I covered the 4 main components structurally of a wine that's important for you to know as a consumer. Alcohol. If you blow out and it feels like you just took a shot of vodka, it's probably out of balance. Sugar. If you have this viscousy kind of mouthfeel, sort of sweetness above 2 grams per liter residual sugar for level of perception, and you like that, party on, Wayne. If you don't, that's what the sugar is going to feel like. So you can now identify what sugar feels like. Tannin, it's going to be that kind of astringent sort of drying effect, like you just went to the dentist and someone put a thing of cotton in your mouth, because those polyphenols, again, are pulling out fats and proteins in your saliva and whatever it is that you're eating. And then you have acids, and acids contribute to like the mouth watering feel. And there's a bunch of different classes of acids within wine, organic acids, that can contribute to the profile of a wine. That's what I want you to know. That's the big important part, is that there are chemical constituents and chemical profiles of wine, and knowing how those things interact and play with each other is really important in deciding if you like a wine or not. What contributes to the buttery flavor? So the buttery flavor can come from a couple of things. The buttery flavor can come partially from malolactic fermentation. So you'll typically see this buttery flavor in a few very distinct varietals. You'll see it in Chardonnays, and you'll sometimes see it in Viogniers, maybe a couple of other Rhone varietals, but notably Chardonnay. Sometimes Sauvignon Blanc, if it's treated a very specific way. It's called Fumé Blanc in California. But you can also get that buttery flavor by aging it in barrel. And so you are doing, and you can also age it what's called en lees. So if you want to just like make the be all to end all buttery Chardonnay, you would definitely go through malolactic fermentation. You might age it en lees for a while, or on yeast and dead yeast cells and stuff like that, because yeast also contribute flavor of kind of butteriness and savoriness to a wine. And then you also are probably going to put it in barrel for a hot second, like a little bit longer than a hot second. So those buttery flavors that you're perceiving as a consumer can come from a bunch of different places. But it's like that trifecta that we typically see in Chardonnay is going to give you that classic buttery flavor. These are rad. Keep asking all the questions, by the way. Jenny from Washington. Oh, hey, Jenny, I'm from Washington too, homegirl. I am from the desert half of the state. I actually grew up, like if you draw an X in the middle of Washington state, I'm from the middle. And so if you're in Washington state, you're actually really close to ice wines. There's a lot of ice wines in British Columbia, up in Canada. And ice wines, we can talk about them later when we talk about Botrytis potentially, even though not the same process. Ice wines are wines that have been left on the vine until after the first frost. And when you get a frost, it physically freezes the grapes, and the grapes are a lot of water. And that water gets expelled. And so you get a higher concentration of sugar to berry ratio. And when you go to ferment that wine, there's residual sugar just by default because the sugar concentration is so much higher in a dehydrated berry. Small world, near Ellensburg area. Yeah, sorta. Yeah. Wenatchee? Anyway, okay. So let's talk about chemicals that create chemosensory impacts in wine. And this is cool because I want to talk a little bit about how to know what you like in a wine for starters. But when I blind taste a wine, and I'm not gonna lie, I'm decently good at blind tasting. I can get a wine pretty frequently. And that's not because I have tasted every wine on the planet. I don't make enough money for that. And it's not because I know that, Australian Semillon is going to be, I don't know, whatever. I know it because I understand what chemical compositions can go into wines. And so we're going to talk about the different kinds of chemicals in wine and what flavors they give rise to. So Wenatchee is pretty country. Oh yeah, girl, I am very country mouse for sure. Yep, I'm a country mouse. Country mouse turned into, I don't know, trying to be a city mouse. So let's first talk about terpenes. So has anybody worked with terpenes before or know what I mean chemically when I say terpenes? Terpenes are a class of isoprenoids. And so the chemical structure of a terpene is a pi bond that's within a chain of carbons. And so they typically have a formula of C5H8. I know terpenes. Awesome. And they exist as multiples in this unit. And the most predominant in grapes are monoterpenes. So you'll oftentimes hear people say like the monoterpene composition of this wine is really high and blah, 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 blah. But there's actually I think, over 15 terpene compounds that have been identified in wine, and they give rise to a lot of different kind of aromas and characteristics of wine. So the most common terpene-driven aromas that you're going to find in wine are like roses or flowers, gardenias, lychee. Yes, you can pick these flavors up in wine. And these, I call them non-cyclic terpenes because we've also identified cyclic terpenes recently. These non-cyclic terpenes are really high in the varietals Muscat, Gewürztraminer, Viognier, Riesling, Torrontés. All these really aromatic varietals have a pretty high terpene composition. And so if I'm blinding a wine, I'm not going to look for like, oh, I've had this wine before and I know exactly what California Chardonnay tastes like, or I know what, freaking Alsatian Riesling tastes like. I'm going to say this has a really high terpene concentration. What wines do I have in my toolkit of my brain that I know are high in terpene composition? And that automatically kind of gets rid of a bunch of options within wine. Terpenes are awesome. They're fantastic. I love, so delicious. Okay. Another class of compounds that we can think about. Oh, wait, I forgot one of my favorites. So terpenes I mentioned are monoterpenes typically, and they have, they're a linear chain that has a pi bond in the middle, and it's within some hydrocarbons and some other stuff. There's also a cyclic terpene called rotundun. Rotundun is cool. So rotundun is a terpene that gives rise to this black pepper, sometimes white pepper characteristic. And this cyclic terpene is really high in Syrah. And so if I'm blind tasting a wine and it's red and I get a very high or very easy to perceive concentration of black pepper, I'm almost always going to go to Syrah. It might be kind of high in Mourvedre and a couple of other ones, but it's not, you don't commonly see, you'll see Syrah bottled way more than you'll see Mourvedre bottled as a single varietal. And I don't consider Mourvedre to be a classical wine that you would blind. But if I get a red wine and someone's like, Caileen, what is this? Blind taste this. And I get rotundun right off the gate, I'm going to kind of go to Syrah. I'm going to keep my options open, but Syrah is one of the things that I'm going to go to. I had Shiraz this past weekend for the first time. Oh, dude, I love Shiraz. What did you think? Shiraz was like one of the first wines that I ever really fell in love with. Shiraz is Syrah, but grown in Australia. So Dan is just like making me incredibly jealous right now. I don't get to drink enough Shiraz. If that's my biggest problem in life, I think I'm doing something right. So, okay. Pyrazines. So pyrazines are a class of compounds that are typically not wine terpenes, but I have like 6 tiny bottles of pure terpenes. Whoa, that's cool. I want bottles of tiny terpenes in my house. So pyrazines are another class of compounds that give rise to very specific characteristics in wine. And you'll oftentimes hear people talk about, you'll oftentimes, like if you're in a really nerdy wine group, that's what I mean when I mean often. Like often for the average Joe? No. I had it with crab, and it definitely was a good pairing for me anyway. I would not pair Shiraz with crab, but that sounds fantastic because I love Shiraz and I love crab, so party on, Wayne. That's awesome. So you'll hear people when they're talking about pyrazines talk about methoxypyrazines or alkyl methoxypyrazines. And these are nitrogen-containing heterocyclic compounds, which means that they have multiple rings, and those rings have different atoms in it. And they give rise to this green pepper flavor. And you'll hear like this green, peppery, kind of herbaceous flavor. And they're oftentimes found in the family of Bordeaux varietals. So Bordeaux varietals come from the Bordeaux region of France. The Bordeaux region is north central Atlantic area. I wish I had a map, but that's where it's at. And the Bordeaux family of varietals, for a long time in Bordeaux, you could grow Petit Verdot, Merlot, Cab Sauv, Cab Franc, Malbec, And those were the noble varieties of Bordeaux. I might be missing one, but those are the primary varietals of Bordeaux. And they're within a family. And so we now know that they go together so well because they are characteristically incredibly similar. And one of the characteristics that brings this family of varietals together is pyrazines. Again, pyrazines giving rise to this kind of vegetative green pepper aroma. And so fun fact, I believe in 1998, the paper was published in Science from UC Davis in collaboration with a university, I believe in Bordeaux, that identified the parentages of Cabernet Sauvignon. Cabernet Sauvignon is a huge varietal. And these two universities worked together, or universities and institutions worked together via DNA footprinting to realize that Cabernet Sauvignon is a hybridization or a breeding of Sauvignon Blanc, a white varietal, and Cabernet Franc, a red varietal. And so Cabernet Franc, Sauvignon Blanc, and Cabernet Sauvignon all have this pyrazinic compound. And so if I have a red wine and someone's blinding me again, and I get this kind of herbaceous-y character, my brain's going to automatically go to Cab Sauv, Cab Franc, if it's a red, Merlot, potentially Malbec as well. Malbec has some high concentrations of pyrazines. And it's going to kind of narrow me down. You can kind of, sometimes as a winemaker, you can like bash pyrazinic compounds away just by over oaking the hell out of it. But personally, I kind of like when I just get a hint of pyrazinic compounds in these wines that should have them because it's expressive of the grape. So we have terpenes, which are very floral and lychee and beautiful. We have cyclic terpenes like Rotundun, which are black pepper, white pepper, which you'll find in Syrah, Gruner Veltliner. We have pyrazinic compounds, which are vegetative, herbaceous, green pepper. You'll find them in Cab Franc, Cab Sauv, Sauv Blanc, Merlot, Malbec. Speaking of Cab Franc, does it ever have a styrofoam or plastic taste to you? A brewery here calls a stout styrofoam pony because of a styrofoam taste. Huh. A plastic taste. Styrofoam taste. No. The only thing I can think of that would give me like a plasticky kind of taste is like sometimes in certain white wines, I get this like, this is dumb, but like rubber band or garden hosey kind of thing, but those are in white varietals. So I'm not sure why they might have like this styrofoam kind of idea in their head. Maybe that herbaceousness is coming off kind of like plastic sometimes because it's not classic in the traditional consumer sense of a wine. But no, I wouldn't describe Cab Franc that way. I would describe Cab Franc as moderately tannic, moderately acidic, high pyrazinic, leathery, vegetative. Yeah, those are the big ones. And then depending on how it was aged, of course, that will change. Okay, volatile thiols. So thiols are very interesting in the sense that they are one of the compounds that's not in the berry. I mean, there's a couple of compounds here that I'm talking about that aren't in the berry, but volatile thiols is one of the area of like current research that's just fascinating because, and this is really common in New Zealand Sauvignon Blanc, and it has to do with the way they make their Sauvignon Blanc in New Zealand. But these aromas have precursors that become cystinylated. So a cysteine group, a cysteine is an amino acid that has a sulfur group on the end. So if you take that sulfur group off of cysteine and you add it to the precursors of these volatile thiols, you suddenly have a sulfur group on the end of your precursor, and that sulfur group is very reactive. And these volatile thiols smell kind of like gooseberry or passion fruit or guava. And these thiols are pretty darn unique to New Zealand Sauvignon Blanc. You'll see what are called mercaptans, which are another group of thiol compounds that we're not going to get into today. But these sulfur compounds can give rise to a lot of flavors. But if I'm tasting a white wine and I get this kind of like gooseberry, passion fruit, guava thing, I'm automatically going to go to, these are volatile thiols. What wines have volatile thiols in them? And one of the biggest ones is Sauvignon Blanc. So the actual chemical that we're talking about here is 3-mercaptohexanol. Pardon. And it, as far as the concentration you're going to see in wines, it's going to be anywhere from like low 20s of nanograms per liter all the way up to like 15,000 nanograms. So depending on your wine and your winemaking, it can be either very low or very high. But regardless, your threshold for actually being able to detect it as an odor is about a nanogram per liter. So in these wines, if they have it, you're probably going to be able to detect it. And anything that smells like a gooseberry or a passion fruit or guava is like A-okay in my book. So New Zealand Sauvignon Blanc is a pretty common varietal for that. Okay, one of my favorites. Anybody else love Riesling? Anybody else love Riesling? There's a few wines that I could just be buried in when I die and I'd be fine with it. Champagne, German Riesling, and like a couple of others, but those are the two that come to my mind. And Rieslings, especially like Alsatian Rieslings or German Rieslings or a few other areas, can be really high in what are called norisoprenoids. So isoprenoids are an aromatic class of compounds that contributes to the varietal character of Riesling and a few other wines as well. And it gives rise to this kind of kerosene or petrol character. Has anybody ever smelled petrol in a wine or kerosene or gas? You know, like when you go to the gas station, you go to pump your gas, and originally it smells kind of like odoriferous, and you're like, oh my gosh, that smells so awful. Sometimes, in my opinion, in wonderful ways, that same smell can be in Riesling. So there was a wonderful, wonderful time in my life when I had a bunch of old German Riesling. I think it was like a 99, and I was drinking it in like 2012 or something like that. And every bottle was just petrol. It was so good. And that comes from a compound called TDN or trimethyl 1,2-dihydronaphthalene. Sorry. And that is another one of those things where if I have a white wine and I'm trying to figure out what the hell it is, and I smell it and I get this petrol-y, kerosene-y sort of gas station nose, my brain goes Riesling and a few other things, but primarily Riesling. So if anybody listened to Evening of Enology last week, we talked to Dr. Alex Whitener regarding integrated pest management and how we can use IPM to help us navigate vineyards and fruit production. So there's one thing we didn't really get to talk about that much, and it's actually a fungus that can sometimes be beneficial called Botrytis. I love Botrytis. Well, when Botrytis behaves, I love Botrytis. So Botrytis is a weather-driven fungus, and it causes a grapevine disease, and it's called noble rot. So this was originally found because you might look at a cluster of grapes. Let's back up even farther. So there's an area in France called Sauternes. And the Sauternes region of France is off the Atlantic. And there are two rivers that I'm not going to say because I always slaughter the French pronunciation, but they meet together in the middle. And there's this area where the two rivers meet and you know, you have like an estuary sort of that creates a very humid habitat. So Botrytis and fungus love humidity. It's their jam. So in this area called Sauternes in France, people saw that their grapes had all this white shit. White shit on the bunches. And they were like, well, my financial life and my wine life thrive on these grapes, so I guess I'm just going to ferment it and deal with it. What we now know is that white sort of fungusy thing is called Botrytis. And what Botrytis does is at a certain point during grape maturation, it gets itself into the clusters and it starts dehydrating the grape. So the dehydration process of that grape increases the sugar concentration in that grape, and it does a couple of other really interesting things to the wine as well, or to the grapes, I'm sorry. And if you get botrytis at the right time and it sucks some of that sugar out and it changes the chemistry in that grape and then it dries out and your grapes don't split or rot past the point of being noble, you get this grape that you can totally ferment and you get amazing characteristics from it. So you might have residual sugar if you're affected by botrytis because, again, it does dehydrate your grape, and when it dehydrates your grape, your sugar concentration increases and your yeast are going to crap out after a while because yeast can survive in a very high alcohol environment but not that high. And you're going to get these wines that have sort of a saffron flavor or ginger flavor, honeyed, waxed. And the Sauternes area that I was talking about, that, Two Rivers, estuary, Atlantic kind of thing going on there. The grapes that are grown there are Semillon and Sauv Blanc. Semillon being a varietal that is really waxy in and of itself. If you are in Australia, you have probably had a fair amount of Semillon. Unfortunately, we don't get a lot of Semillon from Australia here just because of shipping. But it's a beautiful waxy varietal, and Sauvignon Blanc is this beautiful aromatic varietal that's also very crisp. And so if you have grapes that are affected by botrytis, you get this waxied, honeyed, ginger, saffron, residual sugar, sweet, beautiful wine. And so you can get that on dessert wines. You can also get it on dry or off dry wines. And so there's an area called Vouvray, and Vouvray is in France. And Vouvray oftentimes will grow Chenin Blanc, which is a varietal. And Chenin Blanc can be affected by botrytis. And so if I am, again, blind tasting a wine and I get this kind of saffrony sort of ginger characteristic in a wine, I'm going to go straight to botrytis. Maybe not straight. I'm going to start thinking about botrytis as an option. And so, that's a lot of information. I'm not sorry, because I hope this is really helpful. But so what we basically just discussed is we went through and we talked about a few of the main classes of chemicals that you can find in wines. Terpenes being things that give rise to like floral, kind of lychee characters. Cyclic terpenes such as rotundun, which gives rise to black pepper or white pepper characteristics that we can find sometimes in Syrah, Gruner Veltliner, Petit Syrah, Mourvedre. Pyrazine. Oh, hey, Patrick. Pyrazines or methoxypyrazines, which give rise to these kind of herbaceous, vegetative characteristics, sort of green pepper characteristics. And we'll see this in the family of lychee characteristics. Sounds scary. You've never had lychee, Patrick? Gotta get you some lychee. These pyrazinic compounds, which are within the family of Cabernet Sauvignon, Sauvignon Blanc, Cabernet Franc, because again, we remember that Cabernet Sauvignon is the love child of Sauvignon Blanc and Cabernet Franc, and so all these flavors are within the family. You have volatile thiols, which are a function of fermentation, and we'll oftentimes see these, coming into play as gooseberry, passion fruit, guava, and we'll oftentimes see this in Sauvignon Blanc from New Zealand just as a function of their winemaking practices. We have nor-isoprenoids, which are these aromatic compounds that give rise to this kind of petrol-y, diesel-y flavor that's in Riesling oftentimes that I just could flip and drown in. It's so beautiful. And then you have Botrytis, which is a fungus, and that fungus latches onto grapes at a certain time within their aging, dehydrates the berry, sucks the water out, changes the chemical composition of that berry, and when you ferment it, you get these kind of like saffrony, ginger, honeyed, sort of waxy flavors. That's actually all I had. That's all I had 50 minutes later for today. So does anybody have any questions about buying wine, how to know if you like wine, structurally what to think about in wine? Because if not, I got some wine to drink, but I would love to help you. I guess that's what I'm here for, right? Is helping you guys figure out what wines you like. That's kind of my job. Yeah. Alrighty. Well, if nobody has any questions, we can review again. The main structure is alcohol, sugar, tannin, and acid. Think about how those things are going to play into your glass of wine. And then next week, what do you mean structurally? What do you like in wine? Good question. So when I say structurally, what do you like in wine? Some people like high acid. Some people like high sugar. Some people like high alcohol. Some people like high tannin. And so being able to identify what these things are in a glass is important to know for you whether or not you like that thing or not. So I don't know how long, I'm sorry, I can't remember how long you've been in the conversation. I'm such a jerk. But you have alcohol, which gives you that kind of burning sensation. You have sugar, which gives you that kind of sweet sensation, that sort of viscousy, thick mouthfeel. And obviously, well, not obviously, but if it's above 2 grams per liter, it's within the perceptible threshold of most consumers, and you'll be able to actually taste sweetness. You have acid, which will make your mouth water. And your acid can come from a bunch of different places for organic acids within a wine. And you'll have tannins, which are the thing that feels like it's drying out your mouth, because polyphenols and long-chain polyphenols bind directly to fats and proteins, and they pull them out of solution, which makes your mouth feel dry. Some people love high tannin wines. I love high tannin wines with foods that are super fatty and super proteinaceous, because it makes the wine taste different and it makes the food taste different as well. We can get into food and wine pairing potentially in a different episode of Evenings of Enology. But structurally, it's important to know what you like. So for example, I really like high acid wines. I like wines that are low pH, high titratable acidity. I love that mouth-watering feeling. I love how acid can kind of cut fat and wine, but in a really beautiful way. And I know that about myself. And so when I am going and tasting wines, I will seek out wines that are high in acid. Are there combos of acid and tannin or sugar and alcohol? Because then I think I like acid and tannin. Yeah, so that's a really fantastic question. So acid and tannin kind of interplay together, and sugar and alcohol interplay together, and sugar and acid interplay together. Like if you had a 4-way Venn diagram, it would get kind of messy kind of quick. But acid can kind of cut your perception of sugar, and perception is a very important word here. Not like the sugar content or acid content changes once it hits your palate. But if you have a wine that has residual sugar and is high acid, and some fantastic wines are, as soon as you put that wine on your palate, you're immediately going to get sugar, and it's going to be immediately cut by acid. And so in order for you to know if you like high sugar or high acid wines, you need to find a wine that is high sugar and moderate acid, and then a wine that is high acid and moderate sugar, or no residual sugar, because they do cut each other a little bit. As far as tannin is concerned, you also have an interplay of tannin and acid, because if you have a wine that's high tannin and high acid, you're going to first dry out your mouth, because the tannin is going to bind to the fats and the proteins in your mouth and pull them out of solution. But then right afterwards, you're going to have acid coming in, creating this kind of mouth-watering feeling. And so a lovely wine, in my opinion, is fermented dry, if I'm talking about a stilled everyday table wine. So there's no residual sugar. So that simplifies the equation a little bit. But you're going to have a wine that is, if it's a red wine, we'll say, because white wines don't have tannins in the same way that red wines do. You're going to have something that pulls fats out of your mouth, dries out a little bit. You get this kind of flux of acid coming in that makes your mouth water. You have these aromatic and chemicals that react with oxygen to create a very diverse flavor profile and aromatic profile as well. And then you're not going to have this kind of like breathing of vodka dragon sense on the end, because if your alcohol is too high, it's going to burn off all those flavors. You're not going to be able to taste it. And so, again, a balanced wine is like a painting. And if the acid, the tannin, the alcohol, or the sugar are out of whack in a way where it's not compensated by another part of the structure within the wine, your painting is out of whack. So I think it's important as a consumer to know if you like any of these things. And if you taste a wine and you feel any of these sensations too robustly and too negatively, you can say to yourself, I either A, don't like that, or B, I should pair this with some sort of food that can help me combat that. Because there are certain regions of the world, and there's a saying in wine called what grows together goes together. And what that means is, for example, in the Alsace region of France, they have a very high fat diet. And their wines are incredibly acidic, and acid cuts fat a little bit. And so you'll oftentimes have very rich kind of fatty foods to go with those high acid wines. Is there any way to know when shopping for wine, like in a grocery store? Probably not. I already know where you're going, and probably not. How much acid, tannin, sugar, alcohol there is based on the varietal? How much does the winemaker or brand go into it? Unfortunately for you, a lot. So what I suggest doing is, I'll give you a couple points of advice. I suggest going to a wine shop and having no qualms and saying, and you can DM me and let me know where you live, and I can try and find a good wine shop for you, but say, I got 20 to 25 bucks to spend. I want this in my wine. What can you get me? And honestly, the som's probably going to nerd out. They're going to be like, this is awesome. It's like a Sudoku puzzle for wine. And they're going to probably love the fact that you want to find a good bottle of wine for 20 to 25 bucks, because plot twist, in the wine industry, we hate spending money on wine. So most people aren't going to spend more than like 30 bucks a bottle on a bottle of wine. So have no shame, no qualms in going to a wine shop and saying that. We're going to love it. So you can look at the ABV on the bottle. That's the one thing that has to be on the bottle, is the alcohol by volume. And if it's anything above low to mid 15s, I say like back off. It's probably going to be a little too hot. When I say hot, I mean high in alcohol. There are certain varietals that you can kind of count on. Again, New Zealand Sauvignon Blanc is a good example of a classic wine. White Bordeaux is a beautiful example of another Sauvignon Blanc. California is real tricky. Washington Merlots can be pretty reliable and really good. French wines, they've been doing it for frickin' ever, so they're pretty reliable. But no, you can't tell anything about the tannin composition or the acid composition on a bottle, unfortunately, especially for most wines in a grocery store. I'm sorry, it's just the way it is. What I do suggest doing is, every time you have a bottle of wine, and I wish I had actually brought this out, I have a notebook from like way back in the day when I was learning about wines, and every bottle of wine that I drank, I would take notes on it. And so I had a collection after a few months of tasting of, what do I like in a wine? What did this wine taste like? Can I pick out structures within this wine? Can I pick out chemical components within this wine? And I can refer back to that as kind of like my guide for what I do or do not enjoy. So if you really want to get into wine, be that person carrying a notebook around. Like no one's going to be like, oh my God, what a nerd. And if they are like, oh my God, what a nerd, then screw them. Like, you just want to learn about wine. So whatever. But that's a fantastic question. And there's actually some discussion in the industry about whether or not we should be putting acid levels or, tannin levels don't really go on wine because it gets complicated with how tannins change in the bottle as a function of time. Acids as well. But some small producers will put pH, titratable acidity, bricks at harvest, and all that stuff on their bottles. But it's pretty rare as of right now. But fantastic question. And I'm sorry I can't help you anymore. It's complicated. Next week. Sorry, I have 3 minutes left. Hold on. High acid. High acid. So next week, we're going to be discussing faults in wine. Awesome. Thank you. Yeah, message me through either my handle, which is CAIMARISON, or the SciCommunity. I'll be like jumping into the SciCommunity, answer questions as well. So next week, we're going to be talking about faults in wine. And this is controversial. Not all wine is perfect, unfortunately. And I think as a consumer, it's also important to know when wines are faulty. And you should be able to know when to give a wine back, or when to decide that you just flat out don't like a wine because it is faulty. And this is not, I don't like it. It's jacked up. So we'll talk about faults in wine a little bit next week, where they come from historically, where they come from in a winery, and how you can identify those faults as a consumer. And I hope that you learned something today. I hope that you had a fun time hanging out with me. I had a fun time hanging out with you guys. Feel free to drop any messages in either the SciCommunity's page or my page, and I hope that I can answer those questions for you. But for now, it's been awesome. So thank you guys. I got